Welcome everyone, this is a Legacy School Science lesson for Physics Chapter 19 on World Energy Need. For this lesson, you will need your Science Checkpoint Book 3, pages 225 to 240. We are moving towards a time when there will be an energy crisis. A crisis is a time of danger or of great difficulty. We are in danger of not having enough energy to meet our present needs. Try the 4 discussion activity before you read on. Energy pathways on Earth. The sun sends out a huge amount of energy into space in all directions every second. Only a tiny fraction of this energy reaches the Earth. Even so, this amount of energy from the sun is large in our term on Earth. It would take 173 million large power stations to produce the same amount of energy that we receive from the sun each second. However, not all the sun's energy that reaches the Earth can be useful to us. Figure 19.1 shows a Sankey diagram about energy pathways on Earth. It features energy from the sun, geothermal energy, and energy from the tides. It does not include nuclear energy, which is described on pages 232 to 234. So this is figure 19.1, and it shows how the energy from the sun is going with the numbers, and how much energy we're getting from the geothermal and how much energy we're getting from the tidal energy. The water cycle. Nearly a quarter of the sun's energy drives the water cycle on Earth. It heats the surface of the water in the oceans and seas, causing large amounts of water to evaporate. The water vapor passes into the air and eventually condenses on dust. The tiny droplets of condensed water from clouds. Winds push the clouds along, and when they reach cool regions such as high mountains, larger droplets form and rain is released. The rainwater forms rivers, which leads back to the seas. Winds and wave. When the sun rays heat the ground, some of the heat is passed into the air. The warm air rises and is replaced by cooler air. This movement of air generates wind. Some wind blows on the surface of seas and causes waves to form. The movement of air and the up and down movement of the waves can be used to generate electrical energy. Tidal and geothermal energy. There are 2 energy paths which do not begin with the sun. One energy path begins with the movement energy of the tides as they rise and fall due to the pull of gravity of the moon and the sun on the waters and of the seas and oceans. The second energy path begins with the heat energy released by radioactive materials inside the Earth. Fossil fuel. Only a very small amount of the sun's energy is trapped by plants and used to make food. The food is used by plants and animals. When plants and animals die, their bodies decompose and the energy that they possess passes into decomposing organisms, such as bacteria, and eventually passes out into the air and space as heat. In the past, there were regions in the world where this did not happen. The energy in the bodies of ancient trees and marine organisms was trapped underground in their bodies. These organisms did not decay, and fossil fuel, coal, oil, and gas were formed. From one crisis to another, the first fuel that humans used was wood. There was plenty of it around, and the trees grow back at the rate at which people used them. In time, in some countries, the number of people increased, and the demand for fuel increased as well. The trees could not provide enough energy to meet the need of the people, and an energy crisis loomed. Also, the destruction of trees led to the washing away of the soil in floods, leaving ground on which few plants could grow. The possible energy crisis due to tree destruction was averted by the discovery of fossil fuel, coal, oil, and gas. They are the fuels on which much of the world depends today. The problem with a fossil fuel is that it takes millions of years to develop. It cannot form at a rate matching that at which we use it up, so eventually it will be gone.
The problems with fossil fuel. It is quite easy for people to collect wood for fuel. They can just pick up dead branches or chop down a tree. The fuel has then only to be transported, possibly a short distance, to the place where it will be used. When people use fossil fuels, there are more problems to overcome, one of them being extracting the coal. Coal forms in layers below the ground. The layers are called seams. If the coal seams is near the surface of the ground, the soil and rocks above it are removed and an open cast mine is formed. The coal seam is removed and the rock and soil are replaced. If the coal seams are deep, shafts are sunk to meet them and then tunnels are dug into them. The coal is dug out of the seam at a wall called the coal face. It is transported back down the tunnel on trucks or conveyor belts and brought to the surface in lifts. Miners travel in and out the mines in lifts too. Two dangers in the mine are fire damp and flooding. Methane gas escapes from the coal as it's being mined and mixes with the air to form fire damp. If this mixture is lit, it explodes. The buildup of fire damp in a mine is avoided by sinking ventilation shafts and driving a current of air through the shaft and tunnel. Flooding is prevented by building sumps, pits into which water drains at the bottom of shafts and pumping the water that collects there to the surface. Another issue is extracting oil and gas. Oil and gas collect under the ground. Another issue is extracting oil and gas. Oil and gas collect underground in some places where a porous rock is sandwiched between two layers of non-porous rock. A narrow shaft is drilled through the upper layer of non-porous rock to reach the layer of porous rock. The gas and oil pass up the shaft and are carried away along pipes to be stored and transported. Some gas and oil is present under the land in certain countries, while on other places it is present under the seabed. Extracting oil from under the sea requires the building of a platform on which a drill can be set up. The platform also provides a home for the people working on drilling and extracting the fuel. The price of fuel. The price of fuel is related to the cost of extracting it. It is cheaper to extract a fuel like coal when it is near the surface, as the shafts are short and less energy is used on lifting the fuel to the surface. When the coal seams near the surface are used up, deeper seams must be mined. This means making deeper shafts and using more energy lifting the fuel to the surface. This makes the fuel more expensive. In time, it can become too expensive compared to other fuels and the mine is closed. Mines and wells are set up close to places where the fuels are used or where they can be transported cheaply to the people who need them. As these mines and wells are used up, other places where the fuel can be found may be used. These places may be more difficult to reach and increase the cost of setting up mines and wells and of transporting the fuel. Fossil fuel and the environment. When fossil fuel burn, they produce carbon dioxide. As we use large amounts of fossil fuel, large amounts of carbon dioxide are produced. This gas mixes with the gases in the air. The presence of carbon dioxide in the air makes the atmosphere behave like a glass in a greenhouse. As extra carbon dioxide is produced, this effect is increased. This causes the temperature of the atmosphere to rise and result in an increase in global warming. Fossil fuel contain an element called sulfur. When the fuels are burnt, the sulfur combines with oxygen to form sulfur dioxide. This reacts with oxygen and water vapor in the air and forms sulfuric acid. It may fall to the ground as acid rain. When acid rain passes into the soil, it removes some of the minerals from the soil that plants need for healthy growth. The plant's growth slows and they become stunted or even die. When the acid rain reaches rivers and lakes, it causes the acidity of the water to increase. Many aquatic organisms cannot adapt to the increase in acidity and die. In towns, the ornaments, stonework on buildings may be destroyed by acid rain, as shown in figure 19.7. Non-renewable fuels. Fuels are sources of non-renewable energy. They cannot be replaced because the rate at which they form is much slower than the rate at which they are being used up. Radioactive materials are also a non-renewable energy source. Radioactive materials. Almost all the elements forming the matter from which the Earth is made have been made by a nuclear fusion in the distant past. Some elements are unstable and decay in nuclear reactions to form more stable elements. These unstable elements are called radioactive elements. When they undergo radioactive decay, they release particles and energy. Using nuclear fusion. Albert Einstein, a German-born self-taught physicist, began by studying the work of other scientists. Among other enlightened theories, he produced an equation that linked mass and energy. The equation is E equals mc squared, where E is energy, m is mass, and c is the velocity of light. This equation showed that mass is a store of energy, which can be released when matter is destroyed. This idea successfully explained the phenomenon of radioactive materials by showing that they produce energy in the form of radiation because part of their mass was destroyed. Otto Hahn, a German chemist, and Lise Meitner, an Austrian physicist, studied how radioactive materials decay in 1939, Meitner described how uranium atoms break in half. Leo Szilard, a Hungarian-born physicist who studied atomic nuclei, had an idea of how the breakup of one atom may cause the breakup of surrounding atoms and lead to a chain of reaction. When Szilard heard of Hahn's and Meitner's work, he realized that uranium could be investigated to see if a chain reaction could be set up. If such a reaction could take place, then a large amount of energy could be released quickly. Szilard was drawing up his plan and predictions in the United States during the Second World War. He realized that the chain reaction could be used to release energy for a bomb. He and other scientists, including Einstein, informed the United States President of the explosive power of uranium. This led to the development of nuclear bombs. Szilard and many scientists believed that the bomb were too devastating to be used like other bombs and should only be demonstrated in an uninhabitable part of the world to show the enemy the power that was now set against them. However, politicians in charge of the armed force and some scientists believed it right to use the nuclear bombs like other bombs, and two were dropped on Japan with catastrophic results. After the Second World War, scientists began investigating ways of using nuclear energy for peaceful purposes. This meant that the energy released in the chain reaction had to be released more slowly than in a bomb. The nuclear reactor was developed to release energy in sufficient amount to heat water and produce steam. This could then be used to spin a turbine in a generator to produce electricity. Today, there are about 400 nuclear reactors operating in more than 30 countries. Nuclear reactors are built and operated to very strict safety rules to prevent them overheating and exploding. They do not produce sulfur dioxide and carbon dioxide like the power stations using fossil fuel. But the nuclear waste that they produce have to be stored for thousands of years while they decay to harmless materials. So this is figure D, and it shows as the uranium atom splits, and then it causes another atom to split, and then the energy causes another atom to split, and then the energy, and so on and so on. So it becomes more like a chain. Renewable energy sources. Renewable energy sources can be replaced in a short time and so are not used up. One example of them is solar. We can use two forms of solar energy as sources of renewable energy. Heat energy can be trapped by solar panels and used to heat buildings. Light energy can be converted into electrical energy by solar cells. Waves as energy sources. Waves move up and down as they pass by. Machines are being developed to convert the up and down motion of the wave into a circular motion, which can turn the shaft of a turbine and generate electricity. The machines need to be moored in places where the waves are frequent but not too strong to destroy them. Rivers as energy sources. The kinetic energy in moving water in a river is a source of renewable energy. However, the flow of water for providing useful energy for people needs to be controlled. If a turbine was simply lowered into a river and left there, it would spin when the river flowed normally. It would hardly turn at all when the river had little water in it, and it might be washed away when the river was in flood. This was known by the early engineers who set up water mills. They also set up a means of controlling the flow over the water wheel. The water was released steadily from a dam with a loch or a lake behind it. Today, dams are being built to store huge amounts of water to turn the turbines in hydroelectric power stations. Wind as a source of energy. Just as there has to be a steady flow of water for harnessing energy from a current, so there has to be a steady flow of wind for a wind turbine to work efficiently. Obstacles such as buildings can cause turbulence in the air when the wind passes over them, and if the turbine is sited near a building, it may not get a steady flow of the wind to keep it turning smoothly. When wind blows against a cliff face, turbulence develops at the bottom. If a turbine is sited at the cliff top, it will not turn smoothly. So these are pictures of a turbine on a cliff top and the housing being blocking the wind from reaching the turbulence. A hill that rises steadily to a rounded hilltop, then sinks slowly on the other side, is a good site for a turbine. It should be set up at the top of the hill. The wind here will move smoothly over the hilltop, like the air on the aircraft wing, and keep the turbine turning steadily. However, wind is not the only consideration in setting a wind farm. Turbines also make a noise. As the strength of the sound dies away with the increasing distance from the source of the sound, turbines need to be sited away from habitations because they can be very loud and air can carry the sound. So the best place to place a wind turbine will be on top of a round-topped hill. This is the end of this session. I hope to see you again soon.